All right, we're going to be talking about transformations for section 1.4. And as you can see in front of you, I have already labeled all the possible transformations that can take place into a function. So if you are given a parent function without any transformations, if you have a negative in the front, you will have a reflection over the x-axis. If you have a multiple on the outside of the function, you're either going to have a stretch or a compression depending on the value of a. If a is greater than 1, you're going to have a stretch. If a is between 0 and 1, you will have a compression. If you have a negative on the inside of the function, you will have a reflection over the y-axis. Having a multiple on the inside can create either a horizontal compression or a horizontal stretch. If that value is greater than 1, you would have a compression. If it's between 0 and 1, you would have a stretch. Adding or subtracting a value from x on the inside of the function would cause you to either go to the left that many units if it's positive, or to the right if it's negative. And last but not least, if you add or subtract a number to the outside of the function, you will be moving up if you're adding, or down if you are subtracting. Do you have any questions? One thing I do want to bring your attention to is the way that I wrote the inside of this function here. Do you notice that I have the b value factored out? When you are doing transformations, if there is a multiple on the inside, you have to factor it out in order for you to determine the transformations correctly. Okay? So, let's do an example. Pick one of the parent functions. Please don't pick linear. Square root? Okay. So given the following. Negative 2 times the square root of 5 plus 3x minus 1. Determine the transformations. Okay? Number one thing I want you to recognize is, what is the parent function? Should be pretty obvious. Square root of x. Yes? So, the second thing I want you to recognize is that there is an outside of the function, which means it's outside of the radical, and then there's an inside of the function, which is inside of the radical. Cool? What I want to bring your attention is the inside of the radical. Is there a multiple in front of x? Because there is a multiple, then what are you going to have to do? Factor it out. So, first of all, if it bothers you, I can write this as that first. If it bothers you. It really doesn't bother me to have 5 plus 3x, but if it bothers you, you can do 3x plus 5. Cool? Okay, let's talk this through. If I factor out a 3, that's what I need to factor out, right? It's not going to go outside of the root. It's still on the root, right? But let's think this through. If I factor out a 3, what am I left with on the inside of that factor? I definitely need an x, because 3 times x would give me a 3x. What about the 5? If I pull out a 3 from a 5, what am I left with? Definitely 5/3. If you're lost of how do you do that, anytime you want to pull out a number, so like let's say in this case we're pulling out a 3, all you got to do is take the number, which in this case is 5, and divide it by that number. So 5 divided by 3. Cool? Let's say I wanted to pull out a 1/2. That would be like saying 5 divided by a half. Are you guys with me? So always just divide that number, okay? So we have that, and then we have minus 1. Cool? Pretty simple, guys. Tell me the transformations. So we got a reflection over the x-axis, a vertical stretch with a factor of 2. Now, some students brought up to my attention that last year they were very picky about how you wrote, like, if it was like, for example, a fraction, like they would want you to do it in a certain way. I'm actually not going to get very picky about that. Like, let's say there was a 1/2 right here. That would be a compression, right? I'm okay if you just say compression by a factor of 1/2. I know that last year you were told that you would say a compression of 2, right? If you say that, I'll also accept that. I'm not very picky about that part. I don't think that's a major thing when it comes to the math. it still shows me that you know what you're doing. You with me? Okay, so I'm going to say vertical stretch by a factor of 2. What else is going on? So we got a horizontal, what did you say, compression? By a factor of 3, right? What else is going on? We are going to the left 5/3 of a unit. And lastly, we are going downward 1 unit. Okay? Questions thus far? Because I'm going to ask you to graph this. So hold on. Identifying the transformations. Do you feel comfortable doing it? Yes? Okay. Graphing is typically where I see things going south, where students look at this and it's just too much to handle. Because look at this. There's 1, 2, 3, 4. There's 5 transformations. It's just way too much for a student to handle. Okay? So I'm going to show you a way out of doing this the difficult way. The difficult way would be for you to take the parent function and then you yourself, like literally stretching it and compressing it and moving it left and right. That's too difficult. It's doable, but very difficult. Okay? Instead, let me go ahead and, I'm out of paper, whatever. Let me rewrite the function. F of x is equal to -2. We had what? 5 plus 3x minus 1. Instead, why don't you just make a table? Here's why this is easy. You know what the parent function looks like. So if you can get a couple of points, maybe 2, 3 points, you're going to know what this looks like. Are you guys with me? So I'm going to make a table. All right? Okay, here's my x and y axis. Okay. I picked the square root because I want to talk about square roots, specifically about numbers. What is the smallest number that you can take the square root of? 0. Okay. Now, here is where I can help you with this. You got to at least know some arithmetic. I want to know what x value I could put in here that would cause this to become 0 underneath. So I'm going to repeat it again. I need to know an x value that when I put it in here, and then I multiply by 3 and add 5, that's going to give me a 0. Okay. Negative what, I'm sorry? 5/3. Very good. Now, if you're lost as to how he did that, all you're doing, like if you actually want to do work, is you put 5 plus 3x and you set it equal to 0 because that's what I want. I want a 0. Are you guys with me? Subtract 5, divide by 3, right? Okay. So now this is quick. If I put in a negative 5/3, I get a 0, right? What's the square root of 0? 0 times negative 2 minus 1. Guess what? That's my very first point. Yes? You want to know what point that is? Remember the parent function, you're at 0, 0? That's where it moved to after all the transformations. Did I have to think about any transformation? Nope. It just, there it is. Are you guys with me? Okay. Now, I want you, this is the square root. Think of another number that you know that you can take the square root of for sure. 4, you guys are making it too difficult. Go even lower. 1. 1 is a square root, a nice square root, right? So guess what? I'm going to do the same thing, but this time I want it to be equal to 1, right? Are you guys with me? Okay, so how do I solve this? Subtract 5, which gives me negative 4, divide by, so that would be negative 4/3. Beautiful, look at that, so easy. All right, if I plug in a negative 4/3, that gives me a positive 1. What's the square root of positive 1? Times negative 2 minus 1. Oh my God, this is so easy. Yes? Now, I haven't plotted any points because I'm looking at this fraction, so I haven't made a decision yet. And I'm just going to get just one more just so that we can practice, okay? Give me another square root that we can do. 4. Now we're going to do 4, okay? So what do? Set it equal to 4. Okay, so what do I do here? Subtract 5, divide by, so that gives me negative 1/3. Okay, if I'm putting a negative 1/3, what value would I get? Negative 1/3 here, think about it. What's 3 times negative 1/3? Negative 1 plus 5? 4. Isn't that why we use the 4? Okay, what's the square root of 4? 2 times negative 2 minus 1. Okay, beautiful. That's all I need. You ready? Now I'm going to make a decision on my coordinates. Do you guys see how the x's are going by thirds? That's what I'm going to do. Make my life easy. Are you guys with me? So I'm going to say, okay, I'm definitely 1, 4, 5. So I'm going to say 1, 2, 3, 4, 5. I'm saying that each one of those is a third to make my life easy. You understand that? So I'm going to label it negative 1/3, negative 3/3, negative 5/3. Are you guys with me? Now look at the y values. Those are nice integers, right? What do you think I should go by on the y-axis? By ones. So negative 1, negative 2, negative 3, negative 4, negative 5. Are you guys with me? And please tell me we know how to plot points. Yes. So the first point is going to be about right here. Yes. Negative 5/3, negative 1, right? Negative 4/3, negative 3. Negative 4/3, negative 3, that's about right there. Yes? And then negative 1/3, negative 5, that's about right there. Do you remember the shape of a square root function? So shouldn't then this be going like that? Let's see if this makes sense with the transformations you told me earlier. Is this thing reflected downward because there was an x-axis reflection? Absolutely. How much did I get moved down? 1. So remember how I'm typically at 0, 0? Notice how I'm down 1? Did I get moved to how much to the left? So if I was a 0, 0, I got moved left 5/3, down 1. There it is. And then the stretches are a little bit more difficult to see, but everything definitely happened. Okay? How do you feel? Is this doable? Okay? I understand, again, that you guys were not really used to making tables, but is the table idea making sense? All right, beautiful. That's all for today.